Okay, let's share screen and get ready. Okay, tell me if you can see my screen. Believe it's good, right? Okay. Nice. Okay, let's start. So today we have climbing stairs, longest palindrome, and reverse linked list. Let's see. So we did yesterday this tree. Now today we're gonna do this tree, and the rest of the week, Saturday and Sunday, we're gonna do this 6. Okay, let's start by the first one. Try to understand it. We already did this one in the dynamic PLD, dynamic programming. So let's see. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? For example, if they give us n2, which means we have 2 stairs, how many ways we can climb to the top? So let's say this is the stair, step the ground, step 1, step 2. We can climb one step, or we can climb 2 steps. So we have 2 ways. There are 2 ways to climb to the top. First way is one step. Second way is 2 steps. Example 2 is if we have like three steps. So one step, 2 step, 2 step, 2 step, 1 step. We did this one before in the dynamic programming PLD, but we can repeat it because it is in the week 6 program. So let's just do it again. So who doesn't understand the problem, or like who doesn't understand what we trying to do? Or I see a lot of people join, so maybe let me repeat. So the problem here is we need to find how many distinct way we can climb to the top. For example, they give us a stair have 2 steps. How many way we can do, like, and we can only step or like climb by 1 step or 2 step. You know what? Let's take it to our lab. Got this, take it here. Okay, so we have 2 steps. Let's say 2 steps. So this is the ground. 1 step, 2 step. So 1, 0, 1, 2. 2. So if I'm standing here, I can climb. So we can climb by 1 step or 2 steps, right? So I can climb 1. This is 1 solution or 1 way, or I can just climb 2 step like in 1 time. So this is another one. So we have 2.
Didn't we do this?
Yeah, we do this, but
Okay.
because it's mentioned again in week 6, so we will just do it again.
All right.
Fibonacci. So how does you remember how we did solve this? There is 2 way, right? There is what is called bottom up approach, the tabulation, and there's the memoization, top down. We can solve it with both. Okay, we don't need this anymore. But let's say we have 5 steps. 1 step, 2 step, 3 step, 4 step, 5 steps. And we are standing here. Yeah, so we are in step 0. This is step 1, step 2, step 3, step 4, step 5. Now we can solve this. Let's start with what's it called, bottom up, the tabulation way, where we stop. Is it bottom up? Yeah, bottom up. So we know to be here, to reach this step 1, we will need one step, or like there is one way to reach here. And because we're in 0, so there's one way to be in 0, one way to be in step 1, right? Because I can't do from here 2 step. I have only one way, is 1 step to reach here. Now to be in step 2, how many way there is? There is one step, which is this one, like 1 step, or there is 2 steps directly from here. So this gonna be 2 way, right? Now if 3 to reach this step, how many way I can reach here? Again, same, I can go from one step, there's 1, or I can go 2 step, 1 step, there's 2, or I can go 1 step, 2 step, there is 3. And here we notice that it is like a Fibonacci sequence. So this n, or like to get this results of 2 is like this plus this, right? And to get this results is this plus this. 1 plus 2 is gonna 3, so 4 is gonna be 3 plus 2, which is 5, and 5 plus 3 gonna give us 8. 8. Now let's make how we can double check that actually 4 to reach here 4, it's gonna be 5 way. We can say that okay, to reach 4 I can do 1 1 1 1, so 1 1 1 1, right? This is 4. Or I can do let's say 2 2, this is also 4. Or I can do 2 1 1, or I can do what, 1 1 2, this is also 4. There is one more, which is 1 2 1 4. So this is the way, there's 5, so it is correct. And same for this 8. So this is like Fibonacci sequence. So basically the return, like how many way we can climb 5 steps by only 2 ways, 1 step or 2 steps, is 8. There's 8 way. So how we can do this with tabulation? We can use the same array. Before we jump to that, who did not understand or like have question or anything like that? Any question? Don't be shy. Can ask, we can repeat. Also, if you want, like where is it, dynamic for this PLD right here, we did go kinda in details on it. It's worth checking. Okay, let's come back. So we know that now to get to get the number of way, we need to reach 8, right? And we know the 0 is gonna be always 1, right? And we know that 1 is gonna be always 1, right? So we can find a way to generate this array until the n, which is 5, and just keep going. Like the result of this is n, so n minus 1 plus n minus 2. So 1 plus 1, if n is 2, right here, it's gonna be 1 plus 1, it's gonna 2, right? The same formula is gonna be for this. It's gonna be 2 plus 1, 3. Again, we're gonna keep looping. 5 is gonna be like 3 plus 2, gonna give us 5. And for this, gonna be 5 plus 3, 8. Let's write a pseudocode. Please, if someone have a question, go ahead. Okay, how are we gonna write pseudocode for this? Or how are we gonna code it? Let's start with creating an array, right? This array. So let's call it what? Array. We need array. So for us, n is 5, right? N is 5. So I want to create an array of how many elements? 6. Because it starts from 0, right? Is that right? Or yeah, 6, because I want, yeah, so array of 6. So we can do, we can generate array in Python. How? Someone help. Okay, you can do 0. So n plus 1. So this gonna give us array of 6 elements that have 0. 0, 0, 0, 0. Right, so this is what we want here. Now we know this gonna be 1 and this gonna be 1. So we can set it manually. It's just array 0. We're gonna put 1, right? And array 1, we're gonna also put 1, right? Because there is one way to be in step 0, one way to be step 1. Yes, please go ahead. Ibn, please go ahead. Just open mic and talk.
Can you hear me?
Yes.
Hello?
Yes.
Okay, so I just wanted to clarify. The formula you n minus 2 plus n minus 1. I'm looking for the last value is was 7.
Okay, your mic, your mic or something. It's kind of hard to hear you. It's a bit muffled. Maybe you can write it in chat and I read it out loud. Or maybe get close to the mic or something. It's really hard to hear what you say. With me?
Okay, can you
Oh, much better. Let's go. Okay, what you said.
hear me now?
Yes.
Yeah, I'm with you. Can you hear me now?
Yes, go ahead, please.
Sorry to interrupt. I just wanted to clarify something. The formula you used, n minus 2 plus n minus 1, I noticed it seemed to work for all except 8. You know, for example, the part of The part of 5 that has the corresponding value as 8, 5 minus 2, 3 plus 5 minus 1, 4, 3 plus 4, 7. I don't know, does that mean anything?
Okay, so you are saying it doesn't work for this
I
case?
don't, I don't know if you get what I'm trying to say.
Yeah, you're saying it doesn't work for this case.
For 5.
So this
Exactly, for
case,
5.
this case, right? 5. So we can try it. What is n minus
Exactly,
1 here?
exactly.
N, it's gonna be 4. It's gonna be so n, it's gonna be n minus 1. So n in this case is the index, right? So n is like the index. So this index, the
5
value,
minus 2.
so it's gonna be n minus 1. So it is this one, which is 3,
Okay.
3 plus n, which is the index of we're looking here, minus 2, which is 1, 2.
4.
No, it's 1,
Okay.
2. It's minus 2, like we are stepping from this index by 2, which is 2 plus 2, which is 5, right? Oh, okay, so so this is the n. Okay, maybe I shouldn't write n. Let's say e. Okay, I think I know what confuses you, because the n that we're looking for. So let's say n, e, which is the index.
Okay. Okay.
So let's repeat. So so we're looking for 5. It's empty here, right? We don't know what we're gonna put here. And what is the index of this? Index of this place is 4,
It's
right?
4.
4. So 4 minus 1 is 3.
4.
Is 3, right? So we're gonna go to the index 3 and we're gonna take this value.
Minus 2.
So we're gonna go to the index 3. We're gonna take this value. Here is it. And then we're gonna do plus. And then we're gonna go to e minus 2. And e is 4, right? So 4 minus 2 is 2. So we're gonna go to the index 2.
Yeah.
We are here. And we're gonna take this value, which is 2. And we're gonna add it here. And it's gonna give us 5. And this 5 is what we're gonna put here. Is it clear?
No, it's clear. It's the other one I'm referring to. The one having 5 at up and 8 at the bottom. I was trying to say that the earlier formula you gave, n minus 2 plus n minus 1, that if you take 5 as n, that is 5 minus 2, 3. Then for n minus 1, you take 5 again, 5 minus 1, 4. That 3 plus 4, it gives you 7. So I just wanted to be sure if that doesn't mean anything, because, there is written 8. So it was appearing as though that one gives 7, but here's 8. Just wanted to be clear.
Okay, so you are saying the formula gives 7 here, not 8?
I don't know if you get what I'm trying to point at.
Oh, I just don't understand well.
I think I understand him.
Yeah, please go ahead, clarify.
Hello?
He just subtracted 1, 5, get 4, and 2 from 5, 3, then add them together, 7.
7 here?
5.
5 is this.
No,
Exactly.
5 here?
He ignores that we are talking about indexes. He just dealt with 5 itself.
Oh,
5 as a number.
okay. So yeah, so the formula here is the index. I think that was the confusion, not n as like n5. Did you get that, Ibn Zir?
Okay, no problem. Thank you.
Yeah, so like, but did you understand it or not? Did you?
Not fully, but I think I get the idea you're trying to point at.
Okay, so let me repeat this one more time. Now, what is the value of n?
5.
What is the value n here?
Can you
1.
hear me?
Okay, so now the n, when I said the value of n, you said 5, now it's become 1. That is the confusion, right? Because n, let's say n is the number of the steps, total steps,
Okay.
and the value of n here, it's still 5. The value of n here is still 5. Here, it's still 5. But for me, instead of using n, I should use e, because the value of e here is 1. Value of e here is 2 and 3. N doesn't change here.
Okay.
It's clear?
Yeah, thank you very much. Thank you.
Anytime. Someone
Hello?
want to say something, but I didn't hear. Please go ahead.
Can you hear me?
Yes.
Oh,
Yes.
sorry. Yeah, I'm new. Can you hear me?
Yeah, we can hear you clearly.
I'm new to this. Like, I don't know what you guys are solving. The first thing you're solving, so it's kind of confusing what you guys are trying to do. So I don't know. I'm just joining. I don't know. What's
Yeah,
going on.
it's okay. So did you like have idea about LeetCode?
Yes, but not that much though.
Okay, so LeetCode, the place where you're gonna find like a problem and you can solve them using any language, and you can test your code, test the cases, or like submit or even see solution of other people in the community, how did they solve it. So today we have in 3 LeetCode. One of them is climbing stairs, and this problem is about like if I give you a stair of 5, right? 1, 2, 3, 4, 5. How many way you can climb to the top, knowing that you can only do 1 step at a time or 2 steps at a time? So I can do 1, 1, 1, 1, 1, or like mix them 1, 2 step, 2 step, 2 step, 2 step, 1. So there is many way, right? So using like dynamic programming, we could spot that there is a sequence here, Fibonacci sequence, and from that we can write a program using what's called that approach, tabulation approach or bottom up approach. If this is completely new for first time it's here, you're gonna hear it. It's okay. You can check the PLD number 14. We did go in detail about them, about like dynamic programming. So now we spot that, okay, if I am in step 0, I have only one way to be in step 0, right? If I want to go to step 1, I have one way. If I want to go to step 2, I have 2 way, right? So because I can do one step, or I can jump directly to step 2. And the same for 3, for 4, it is 5. And at the end, we're gonna find out 8 to reach to the top, which means there's 8 way I can reach to the top by mixing 1, 1, 2, 2, 2, 1, you know. Now we wanna create the same, we wanna somehow generate this using Python, generate this array. We know this is gonna be fixed, right? Because 0 is gonna be always 1, 1 is gonna be always 1, and from this we create this formula, which is if we wanna the value of the index 2, we're gonna just do sum between the last 2 previous what is it called, elements, right? So 1, 1 is gonna give us 2. Now I wanna find the value of the index 3. I'm gonna do 2 plus 1, it's gonna give me 3. Now I wanna find the value of index 4. I'm gonna do 3 plus 2, it's gonna give 5, and we keep going, right? So I hope that's cleared a bit. If you have any question, please go ahead.
Okay, thank you. So basically we are using Palindrome method to solve the question, right?
We are using tabulation or bottom up approach. we're gonna just create
Okay.
array and use the previous value to find the next value. I'm sure if after you like watch the PLD 14, you're gonna understand what's going on, because we did the same example too, the same.
Can I
dish.
ask a question?
Yes, please go ahead.
I know that you came to this solution because you came with that problem once before. If the question was asking مثلا like there were 3 ways to climb the stairs or 4 ways, what approach will you solve this problem in that way?
I have no idea, to be honest, but I'm sure we can find a way using like tabulation or memoization, right? But I don't know, like I have no clue. We can brainstorm, think about it together, and see what we'll do. So basically, let's say we have
3 ways.
3 ways, like 1 step, 2 step, or 3 step. So instead, like we can keep the same principle, right? It's just the number here gonna change. For example, if we are gonna go to step 2, let's see, step 2. Now to go to step 2, we can do 1 1 1. It's gonna stay the same, right? Because we can do 3 step. So maybe it's gonna work in. So this is gonna be still the same, but at 3 we're gonna have probably 4 way, because it's gonna be
The 3 itself.
it's gonna be 1 1 1 2 1 1 2 and 3. So it's gonna be 4, right? And then we're gonna see 4 again. It's gonna be what is gonna be, it's kind of hard to simulate. Let's see.
I think the question here is the equation that will depend on it.
Yeah, to find the pattern, right? So but to find,
yes.
after we find, let's say we find here let's just send randomly, right? Randomly, I don't know if it's true, and this is for example 10. Then we're gonna try to see if there is a pattern, a formula like this that will use the previous values to generate the new values.
Well, I think there is a pattern. يعني in the 3 we combined all the values I minus yes
3.
You found.
Okay, we can okay, let's note this, right? We can come back at the end of the PLD. We see if we can do something like this.
Okay.
Now let's code this one, and then after it we finish the 3 let's code, we can jump, because this is gonna be fun, because I have no idea too. Be happy to learn it. So going back to the pseudocode, so we generated a array of 6 elements. We put 1 in 0 and 1 because they're gonna be always 1 1, right? Now how we can fill this, how we can fill it, any idea? How we can fill 2. So fill 2. So let's say do it like manually. Here, what is that? Index 2, right? 2. It's gonna be what? E minus 1. It's like E minus 1 plus E minus 2. But we wanna loop. So let's do like for e. Okay, for e 3 n plus 1. Okay, so for e in range. Now 3. Is it 3? We're gonna start from here, so 2. But if we did 3, then we probably should do array 2 equal 2, right? But let's just keep it 2. So we want the loop of, because we're gonna loop on this. We're gonna loop on this part right here. This is what we want to generate, because we have one here, and we want to generate the number here. So we are saying range 2, which means starts from 2 until n. N is 5, but I have in this array 6. Right? So, but that if I write 5 here, it's gonna count until 4. So I need to do, okay, so this index right here is 5, right? And this index is here is 0. Now if I did the range 2, 5, it's gonna go from 2, 3, 4, and it's gonna stop. This is how range work. Now I need to do n plus 1, so it's add 5. So here n plus 1, which means the value here is gonna be 6, which means it's gonna count until 5. Now array of e, which means like each e we are looping through, is gonna be array e minus 1, array minus 2. Okay, what else? Now we have all the value, then we're gonna return the last element, right? Because this is gonna keep looping to here. It's gonna put 2, it's gonna put 3, it's gonna loop again, put 5, it's gonna loop again, put 8, and when it's finished, I return the last value. Return. Last value, it's gonna be array minus 1. Okay. Anyone have question? Okay, if not, let's jump to the LeetCode, see if this is gonna work. And did I forget anything? Probably fine. Run it. Do I forget? Array e plus, oh, minus 2. Run. Okay, nice. Submit. Okay, not bad. Okay, someone did solve it in a different way. 1, 2, 1, 2. What is that? Tuple 1, 2, and then you loop through tuple, and you just add. It's like you flip them. Oh, you flip them, right? You flip them and you add the 1 with 2. That's smart. Now, can we do this with? So this is bottom-up approach, right? Can we do it with the recursion one, the top down approach? for like memoization? Of course we do, right? So because this is like Fibonacci, so if we want to like create a Fibonacci sequence, how we can do that? So let's say we are using, let's say results equal, and we did like climb n, and so the Fibonacci gonna stop when you're gonna like reach 1 or 0 I think. So if n equal 0, Fibonacci of 0 is what? Return 1. And then the results n, we're gonna call climb n minus 1 plus climb n minus 2, and we're gonna return the results in what you said, if n equals 0 or n minus 1. I think yes, so 0 1 1 0, but do we need to write them both? Yeah, because we one time we do minus 2, one time we do minus 1, so one of them might skip 0, and 1 minus 2 is gonna be minus 1. So yeah, so or n equal, so this is the base case. And if we print the climb number 5, it should give us 8, right? So 8. So this is Fibonacci, right? Basically we launch recursion. We launch recursion on this. So we start from 5 and it did recursion until we found the result 8. Now this can be improved using dynamic programming to like reduce calculating the same value again and again. For example, if I print here, print, I am calculating value for n. Now let's see. Okay, notice we calculate the value for 2 twice, even if it is the same, right? It is the same value, so why we are calculating 3 here and we again calculating here? So the idea of memoization is like, why not save this tree somewhere, and then when we want it here, we don't want to calculate it again, we're just gonna get that value, and this way we're gonna save this time. So I did create on purpose this hash map to use it to like, this gonna be the memoization for it. So let's see how we're gonna do it. So let's put, so the first results, we don't want this line to calculate it if n already exists in the hash map. Now if I print, for example here, print results, so I'm gonna calculate, let me print just so we see where it starts, where it finishes. So I'm calculating 5. The hash map doesn't have any 5, so it's okay, I can calculate 4 3 2, but I'm calculating 2 and I have it already here. Why not skip this and just take the value direct? 3, I'm calculating 3, but I have it already here. So I need the line here is like if n already in the value results, if n is not, so like we can do like if n is not in the results, then you can enter here. Is not, how do I write is not? Not in, not in. If n not in results, if n not in results, then do this line. Is it not in? Can someone confirm? Okay, so not in. Okay, let's see if it's gonna enter again here. Let's print the same thing. Run. Okay, notice it's become like the number of calculation is to reduce. 5, 4, 3, 2. It gives us 8. Just because we save time with this. So this is memorization. We can use the same. We actually can use the same code to solve this, because if you notice this code, it's like Fibonacci, right? So we can use the same code too. By the way, who does have any question, please just open mic or write in chat. Don't be shy. We are all here learning. We can do what we can do. So instead of claim, we can do claims there. And the results, we can do results hash map. We can actually put this value directly in the hash map itself.
The result hash map should be outside.
Outside. Okay, confused. What you mean outside? So like here?
Outside the function? Yes.
Oh yeah, because it's gonna keep resetting. Yeah, because it's gonna keep resetting the value. Okay, so let's run.
Need the class name, I think.
Okay. Okay, do you know how to do that? Because I don't.
Solution dot, يعني what's a class name?
Like this?
Yes, try. Return also.
Solution.
Line before it.
Okay, that is too much solution. Okay, let's do it maybe. You know what? Let's do
Okay, you can make it a class member or
yeah, maybe create a function and put it inside. Like put this here. And climb in. Oh no, this there. And this gonna jump here, this climb. Solution, remove it. Results in. Think. Oh, dots.
You didn't use the climb itself. You're just recalling the result.
What do
Okay,
you mean?
okay. We didn't call
Oh,
it.
I don't need to do self because it's inside. So just climb.
Okay, but we need call it outside. Climb itself, we didn't call it.
Or return climb, not return results. Climb n. So we're gonna give climb n, and it can
Okay, and
return. So it's
like
meant to return the results.
yes.
So climb, it's gonna return the results. Okay, finally. Let's see, is the performance better or not? No, it's not. But it's, yeah, so this is memoization approach. Top down. Yeah, it's really hard to think about this, but what is called the PLD 14, we did do like top down and bottom up. I think if someone confused, just like watch the PLD 14. That's it, I guess. If someone have question about top down approach that we did or the bottom up, please go ahead. Also, thank you, Mina William. Thank you so much. Okay, who have question? Don't be shy. We are learning here. Okay, any question? I'm sure you have at least one small question or big question. If not, let's move to the next LeetCode. Let me write this code here. And let's go to the next one. It is longest palindrome. So, given a string s which consists of lowercase or uppercase letter, return the length of the longest palindrome that can be built with those letters. Letters are case sensitive. For example, A is not considered a palindrome here. S, E, B, C, 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 D, D. So the longest palindrome here is 7 that we can create with these letters. Explanation: one longest palindrome that can be built is D, C, C, A, C, C, D, whose length is 7. A have one longest palindrome. S consists of lower and or uppercase English letter only. The length can be from 1 to 2000. So, given a string h which consists of lowercase or uppercase letter, return the length of longest palindrome. So, let's take it to the lab and try to understand it more. So, do this like this. And what we gonna do? So we'll say A, B, C, D. Okay, so A, B, C, 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 D, D. So with this one, we can have the max longest palindrome is 7, which can be it can be D, C, C, A, C, C, D, or D, C, C, B, C, C, D, right? This can be one of these, the longest. Of course, we can like flip them. It can be this one right here, this one right here, but it's same length. Now how we can calculate from this string what is the max length we can generate from these letters? Palindrome we can generate. Now we know palindrome is always gonna be two cases. Gonna be this case. It's gonna be either this case, let's say 4 4, which this side equal this side, or 4 4 1, where there's a character in the middle, which this side equal this side, but there's a character in the middle, so it's gonna be palindrome. Okay, who have any idea, or like who doesn't understand the problem? Then we brainstorm how we can solve this. Anyone? It is a tricky one. Okay, let's start from this character. Okay, we know this one right here. We know it is 7. Let's start from it so we don't get lost. So we can calculate how many characters we have, right? So for example, we can create a hash map. We have A, okay, A is 1. We have B, B is 1. C, C is 3 character. D, D is 2 character. Okay. Now, wait, C4, not as the example they give us 4C. So this one is 4. 4. Now we know that the palindrome is gonna be like this or like this. One character here. So what we can do is check if the number, if odd or even. We need always 2 same letters, and if there is extra letters single only, we take 1 also, and that will be the longest length. We need always 2 same letters, and if there is a extra letter, we take 1 also, and that will be the longest length. Yeah, so like the odd and even kind. So let's say the length, this is the variable length. Let's say it have 0. Now we can add 2 to it. 2 plus 4 plus, we can't add 1, right? Because if I put B here, I need another B here. So because this is even, this is odd, I'm not gonna add it, but I can add it here. So let's split it in two like steps. First, we focus on this part, the length. Let's calculate the length of this. Then at the end of everything, we see if we have some leftover or like some character are alone. Then we understand, okay, we can add 1 to this. We're not gonna add them all. We're not gonna add like 1 plus 1 2. No, we need only 1. So the length gonna be plus 1. So in this case, we know it is 7, right? But how did they do it? So we did 2 plus 4, which is what? 4, 5, 6, 6. So 3 character here, 3 character here. But because we have leftover, which means if you notice here, we can put A here, or another palindrome we can put B. Because we have 1B, 1A. So we can choose this or we can choose this, but they're gonna be always 3 on this side, 3 on this side. So we can calculate the length with this 2 plus 4, and then if there is any odd characters, we're gonna just add +1 here, +1, even if there's 10 odd character, because we can only add one character of them here. So 3 plus 3 plus 1, 7. Now to clarify some more, let's change b to number 3. Let's change b to number 3 so it's be more clear. Let's say this is 3. Now what we're gonna do is 2, it's even number, right? So add it directly. 4 is even number, so add it directly. 3 is not even number, but it is odd.
Yes, we will divide each number, despite its odd or even, by 2.
By 2. Yeah. Yeah, that's
And
also an idea. Yeah,
Okay.
keep going, please.
Yes, we will take the remainder and keep it in a variable, and see that that variable at the end, if it has any value, we will
add 1.
Yes.
Yeah, that's smart. So even if d is 3, we'll use 2 only, so we will divide the count of the letter by 2. The divide part that I didn't understand well. Why not just like if it is odd, we can just do 3 minus 1. Right, like the value itself, we add the two character we need, and then we like see if we have like the variable you said it's gonna be maybe boolean or like a flag. Then if it is odd, we raise the flag become true, and then at the end we see if the flag is true, we're gonna add +1. In this case, it's gonna be 2, 4, 5, 6, 7, 8, and here it's gonna be just 2, so 8. So this way we have 4, 4, and because we have one left over from here, we're gonna add +1 here, which is 9. So the longest palindrome we can create with this is 9. Even if we remove this a, it's still gonna be 9. Okay, who have question or something not clear about this method to like solve it? If we add numbers which are this one than 1, then we check if the sum is even. We add 1 if sum is otherwise we return sum. Okay, we add the numbers which are less than 1. Or you mean odd, even? I didn't understand, Yasin. Okay, Leila, okay, let me repeat. Okay, 3 plus 3. Okay, so let's do this example. 3, 4, 3. Okay, 1 second. Let's say we have 3, 3, 4, 3. So 4, 3 or 3, 4, 3? Three 40 or 2 40. Let's do 3 40. So if we have 3, 4, 3, let's say B, 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 C, 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 D, D, D. So the longest palindrome we can do with this is,
I guess there has to be two even numbers first.
yeah,
Then
so in this one there is 2 even number, right? So we can take
it
2
has to
from
be
here
two,
and save 1.
3.
3, 4, 3.
No, 2, 4, 3. For
Two-
example, yeah, 2 even numbers plus.
Yeah, but this is also can work.
It couldn't. Yeah, we can take 2. Yeah.
Yes, so like we know this is 3 is odd, so we're gonna take only 2 and we're gonna save 1. This is 4, we're gonna take 4. And this is 3, we're gonna take only 2 and save 1. 2, 4, 2, which is 8. And because we have left over, we can take them all, but because they exist, we're gonna add +1.
Yeah.
So it's gonna have, so the palindrome we can create with this character are 9, the longest one. Okay, Leila said didn't understand. Well, is like there's something specific, or like I will just I can repeat just generally the idea. (3D) 3A is gonna give 6, but this is not palindrome. 3D 3A. Okay, we can start. Okay, but I understand this. If it was 3A, so let's say this is A, this is 3.
I was commenting on one. No.
Okay. Okay, let's
You go.
Okay, let's try to explain the method. So let's do the same example, right? 3, 4, 3. Now 3, 4, 3, it's gonna give us what? B, we have 3 character. C, 4 character. 3D. Now we have these characters and we wanna see what will be the longest palindrome we can create with them. And we know that palindrome is gonna be 2 cases, either the first case or the second case. What does mean? That means either the character in this side are equal in this side, or the character in this side equal in this side, but there is a single character here. So for example, let's create palindrome with this. So we have B3. We can't put B, and B, right? Because they need to be equal. This is not gonna be palindrome. So we need another B here. But we have only 3, right? We can't generate 1. So we need to delete 1. Now that we're gonna delete 1, we're gonna just put this 1 here. What that mean? That mean we put, when the number is odd, we're gonna do -1 of it, so it's become 2. And now we understand, okay, we can generate from B 2 character. So now the length of our letter, if we count it, 1, 2. Okay, the length is 2. Plus, we're gonna go to the C. We're gonna see that C is already even, so there is no need to do anything. Just put this right here. So +4, because I can put C, 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 C. Right? Now we're gonna go to the second number. We're gonna notice that it's not even, so we need to do -1. So it's become even. So it's gonna become 2. Now that this is 2, I can put D here and D here. Now what is the length? The length is +2. Now this is the palindrome format 1. We can also do this one, which is gonna be C, C, B, B. Okay, what did I do here? do it like this. So it's be like a palindrome. Okay, so B, C, C, and I can put any character here from this one that I have left over. This one, I have one B that I didn't use, and I have one D that I didn't use. So I can do two palindrome with one gonna have B here, or another one that's gonna have D. Right? So what is the max length? The max length is 2 plus 4 plus 2 plus 1, because in this case I have left over. Even I have 2 left character over, I just gonna put 1. Even if I have 100 left over, I'm gonna put plus 1. So the length of my palindrome is this, 489. So any question? I hope it like clear. Okay, so now we can keep the same steps and try to convert them to a pseudocode or like a code directly. We can let's just remember how we did do this. So what we did in the beginning, we did calculate the character. So let's split it to two phases. Phase 1 calculates or like calculates the frequency of character here. We're gonna have this hash map. And the phase 2 is we're gonna check if phase 2 is when we're gonna add the count of this character to the length variable, right? So we're gonna check if it is even or if it is odd. If it is even, I'm gonna add that length of number directly to the length, but if it was odd, I'm gonna do -1, then that value I'm gonna add it to the length, and I'm gonna raise a flag. This flag, what is gonna say, hey, I have left over. And from that flag, I will understand that after I finish this, I'm gonna do +1, if that flag is right. Now, how we can do this? Let's say, how we do count the hash map. Let's create a hash map. Hash map is empty. How do we put the character in the hash map? So we're gonna loop on string, right? For each character, let me zoom a bit. In the string. Okay, what I'm gonna do? I'm gonna add it to the hash map. So let's call it just hash. So hash of that character, I'm gonna put it inside here. Let's do +1. Okay, we can't do +1 because the hash is empty, but we can do the so yeah, let's keep it simple now. Let's say we're gonna put +1. Later when we code, we can check how we're gonna do that. So we're gonna loop through each character and we're gonna add +1, right? So 1, and if we find the same character again, we're gonna add +1. Okay, now we have, after we finish, we're gonna have hash map with all character. What was the second phase? The second phase is we can loop on the hash map and add to the length. So let's say this is the length. The length is 0. Now we can loop on the hash map for let's say number like 343 in what? In the hash map, right? Hash map. Now how I can access the value of the hash map? I can do item like this, or I can do value, which is gonna loop through 3 4 3. Okay, now if that number is odd, if num, or let's say even, so for example, like here value a modulo 2, so 2 equals 0, which means it's even. Okay, if it is even, I wanna length, add the length, length or no, I wanna add it to the length, so the length gonna be plus none. Else it means it's not even, right? So it's odd. So length gonna be plus equal num, but we wanna do -1, right? We don't wanna add num because we know it's even, so we're gonna add just -1, num -1. But because it is odd, we need the flag. So let's raise a flag here, flag. False. And here, flag true. If this flag is true, that means we have an odd, or like we have a leftover, which means we need to add them after we finish. So if flag, which means it's true, I'm gonna do length +1. Plus equal 1. And we should return the length. Okay, so this is what we did here, right? I'm sure there is many way to do this. I see some of them in the chat. You can like check them out. But before, let's see if this is working or not. Okay, we have a question about like the pseudocode or the code that's right here. If not, we can take it to the LeetCode and let's see if it's gonna work. Okay, flag, and okay, I think that's all. Oh, S. Oh, there's a problem here. Is this +1? So we can do a hash character, or like hash get car or 0. Is it like this? So this say like, so because when we're gonna add like 1 to something that exists, this get, it's gonna say, okay, go get character that we're looking for in hash map. If you didn't find it, it's gonna create it and give it 0, or like it's gonna it's gonna give it a default value 0. So when we're gonna add it, it will be there. Literal. If we're using a default dictionary, we don't have this problem. Okay, it works. 77, lucky number. Nice. Let's see if it is Okay, 69. Okay. I hope you guys understand it. It is confusing a bit. Okay, who have question about like the code or like the pseudocode we did use to solve it, or the problem itself? Please go ahead. Okay, let's see your solution, guys. For example, this one. What did it use? How did it work? You wanna explain it? Ningasi? Can't. Max odd. Which way? Okay, what about this? This one fail. You wanna explain, Yasin?
No, I didn't use the hash. I didn't assign the values within the hash map.
Did it work?
No, it was almost the same logic you did, you know.
Okay, my hash. So you did the hash, right? Hash
Yeah,
here?
I didn't.
My hash. Okay,
but
yeah,
if
so this is...
assign the values within it. It's almost the same.
Yeah,
like
yeah. Odd if it not minus n. Okay. Okay. I'm curious. Let's see what other people did. Let me post this one. Let's see what other people did. Like solution, Python. Python. Okay. They also checked the even and odd, but didn't use flag. Which way did he use here? Odd count. Oh, they use odd count. So it's kinda like a flag. If the odd count is less, he's gonna do... Okay, so they use a flag but different way. So wherever there is a odd character, they add it, and then the length minus odd counts plus 1. What the point? Because you're gonna add only one character. Why you gonna yeah, but yeah, okay. That's nice. Okay, we can go to the last LeetCode if no one have question. The last LeetCode is gonna be about reversing linked list. I hope you guys didn't sleep. So, how are we gonna do this? How we can reverse this linked list? Who wanna like jump and try to explain? We're gonna solve this. Given the head of singly linked list, reverse the list and return the reverse list. 1, 2, 3, 4, 5. It's gonna become 5, 4, 3, 2, 1. I wanna explain this using Python. Come on, must be someone can do it. Take this to the lab. Let's see. We'll maybe have to use temp variable. I think I remember with the help of 2-pointer. Okay, that's a good solution. Let's start with it. So we have 1, 2, 3, 4, 5. And at the end we need to find that we have 5, 4, 3, 2, 1. 2 pointers and temporal variable. So how we can do this? So one like this, like this, like this. So one pointer here, one pointer right here, previous pointer and current pointer, and temporal variable. Okay, let's say temporal variable is this, temp. Now if I am here, like, okay, what I like to do is I always like to start from the middle of, because it makes it more simple. So if I am here, 3, what do I want to do to make 2 is next of 3, like this. So let's call this current, and this is previous. So current, how are we gonna do this? So current next, right? Current next gonna equal the node that's behind, which is previous, right?
I think we need both, one before and one after, because we when will remove the next pointer,
We're gonna lose this.
We will lose the after one.
So we need to save it. We can put this in temp. So we have temp. We're gonna put the current next. Current next. So here we have 4, which is this one. Now we can break the next, and we still have access to 4 in this temp. Okay, what else? Now we create current next. It's become previous. So it's like we have 3 next pointing to 2. But 2 is still pointing on 3. Do we need to change that? Or not? Maybe not.
I think this will be the case, because if we started the 1, we will not have that issue. The first one we will already have reversed it.
Oh, okay, yes. Because I'm starting from the middle.
Yes.
Okay, so after I did this, I'm just gonna move this to here and this to here. So it's gonna be previous gonna equal current.
Let's assume that the 2 is already have an arrow pointing to 1.
Yeah. So like we're gonna be looping, right? So this gonna move to the next node, which is current.
I think that be the last step is to move to the next one. The first step is to change the direction of the arrows.
Okay, we did change them here, right? Because the current of this is pointing on 2.
Yes.
And now I'm gonna loop again. But when I'm gonna loop, I wanna change. Like I wanna change the 4. The 4.
Yes.
Right? So this currencies need to be this, and the previous gonna be the one before.
Yes. We will start from the previous. Previous will be the current.
Current
will be the current of next.
Current's gonna be what?
No.
Current's gonna be 4. So 4 we lost it, so we have it in temp.
We lost it, yes.
So it's gonna be a temp.
Okay, yes.
Now let's go back from the beginning that we have the core. We can go back to the beginning, which is here. Now okay, now this is gonna be none. This is gonna be the head. Okay, so we're gonna go 1 temp current next, which is gonna be 2. This is the current next. Current is 1. And then the current next gonna be equal previous. So current next gonna be equal previous. So 1, the next of 1 gonna be equal previous, which is none. So none. None. So let's do it like. Okay, so currents next, previous is none, and that's what we want, right? Because 1 gonna be the last node at the end of the list, so it's gonna be pointing on none. Now the previous gonna become equal current, so previous gonna become equal current, which is 1 here, and the current's gonna become equal temp, which is 2 right here, which is 2, which mean this one 2. Now we loop and we treat this. So the loop gonna be while what? Let's say while something. I don't know what it's gonna be. While probably current. Let's just say there's a loop now, then we can think about what the condition of while.
I think while temp.
While temp. So temp need to have something in the beginning before we enter. So previous gonna be none, and the current.
It can be current and have the answer at the previous. Eventually, at the end, it will be previous will be the new hit.
Okay, let's just in this while we'll know, like, okay, while x, we still didn't figure it out until we see how this simulation gonna stop, and then we come back and fix it. So we loop, and when we loop, current is on we have 2 pointers, so the current's red and the green. So this is red. Guess I can't change the color. Let's say this is current and this is previous. So when we loop, temp gonna be current next. Current is this, and the next of current is 3. So this gonna become 3. The temp. This is just temp variable. Inside this temp variable we put 3, and then we move current next. We're gonna change it. Now it's gonna be pointing to previous. So 2, the next of it's gonna be on previous 1. So if you remember, we're building this list right here. So it's gonna become 2 current next, 2 pointing on 1, because current is 2 and current next, which is this line right here, you're gonna pointing on previous. Previous is this one, previous is 1, so current 2 pointing
I'm sorry.
on 1. Yes, go ahead please.
Yeah, so I have a question right there. So you said temp is holding the value, not the pointer, right? So it's holding the value of 3.
No, not
So,
the value,
but when you...
the node itself, like the address of the node.
Oh, okay, the node. Oh, okay, okay.
Yeah.
Okay, that makes sense then. All right.
Okay. So what we doing? So we did current next equal previous. So current next equal previous, it's become pointing on 1. Then we're gonna do previous equal current. So previous right here, it's gonna become current. Current is this one. If this one equal current, it's gonna jump to here. Then current equal temp. Current is the red one. It is temp. Temp it is 3, right? It's like holding the reference address, right? So it's gonna jump to here. 3. Now we're gonna loop again. We're gonna do the same thing. Temp is gonna become current next. Current is this. Next is not 4. So this gonna become 4. And current next gonna become equal previous. So current next is this line right here, is will be pointing on the previous, which is 2. So 3 next of it's gonna point on 2. And let me lower this. Okay. And then previous gonna be on current, previous gonna be on current, then current's gonna be on temp, which is 4. It's gonna jump to 4. Again, we're gonna do the same thing. Temp gonna hold the current next, which is 5, and then current next gonna become equal previous. So current this one 4. Next of it's gonna be on previous, which is 3. This is previous. And current's gonna be called ecom temp. So current this one gonna go to 5, which is this one. And previous is also before previous gonna move to current. So previous gonna move to current, and current's gonna move to temp, which is 4, 5. We're gonna loop again. Now when we loop, we're gonna do the same thing. Temp gonna be current next. What is current next? Is none. So this gonna be none. And current next gonna be equal previous. So current next gonna be previous. So current next, what is it? Is 5. Next to 5, what is gonna be? It's gonna point on previous, which is 4, right? Because this is previous, which is 4. So current next, which means the current next pointer gonna point on 4, which is this. And previous gonna equal current. So previous, which is this, gonna equal current. And current gonna be equal temp. And current gonna be equal temp, which is none. Right? And I don't wanna keep looping now. So what is the condition that will stop this? I guess it is current, right? Because current in this case is none. If it is not, it will stop the loop. And that's it. We have our linked list reverse. We're just gonna return 5. And what is 5? It is the previous. We can return previous, right? Right? Because notice previous is holding 5, or like it's pointing 5. So after the loop end, I can just return 5, because 5 is become the head here. Return previous. Okay, I guess that's it. Okay, Nyangasi, thank you. Okay. Who have any question? Who have any question or is it not clear? So let's see if this can work. So we have head and current, temp, current, next, current, temp, return, previous, run. Oh, none, uppercase. Nice. It work. Okay, that was nice. Okay, who have any question? Please go ahead. If not, that was it, guys. We solved 3 LeetCode. Hope every LeetCode is clear, and yeah. So next session gonna be Saturday. Majority elements at binary, diameter of binary tree. Then the next session is Sunday. So each week we do session in Tuesday, Wednesday, Saturday, and Sunday. Okay, see you guys next session. Have a good night, and thank you for being here. Who is this special character? Okay, have a good night, guys.